Hello Pre-Calc BC. Today we are going to start plotting and identifying polar graphs, which is a pretty exciting step in your mathematical careers. So get ready. We're going to start with theta equals 3 pi over 4. This is kind of a unique problem. 3 pi over 4 is right here. Right? And notice there isn't anything about the radius. So what that really means is the radius doesn't matter. This is just the whole angle of 3 pi over 4, and you're actually going to go all the way through. This is actually a line. Should be a little straighter. Now, we can be a little more specific about what type of line it is. If you take the tangent of both sides, okay, and you would get that the tangent of theta is, well, tangent of 3 pi over 4, that would be -1. Well, tangent, we should know, is really y over x, right? Or sine over cosine. That is also what we use to show slope, change in y over change in x. What this is really telling you is that the slope of this line is -1. And it passes through the origin, so this is really the line y equals -1x. Pretty crazy. Okay, again, this is a more unique situation that you won't see very frequently. Now let's look at number 2. This is actually going to be another line. How do we know? Well, our sine theta, we should know is y. So this is really the line y equals 2. So I know this isn't a rectangular grid, but all you have to do is just go up 2 circles, 1, 2, and we should know y equals 2 is a horizontal line. So you're just going to draw yourself a horizontal line. Horizontal line of y equals 2. All right, so then number 3. Number 3, our cosine theta, we should know is x. So this is not a horizontal line, it is a vertical line. And we'll just go 1, 2, 3, 4, and then there's your line. Now, these last 3 are going to be circles. R equals 4 is simply saying you have a radius of 4. So we're going to go 1, 2, 3, 4, and really you're just outlining this circle right here. Circle. And the way that we would write this in rectangular form, we talked about this in our last lesson, is that we could square both sides and get r squared equals 16, and r squared we know is x squared plus y squared. So this is a circle with a center at 0, 0 and a radius of 4, because again, this guy right here is going to represent your r squared value. Now, here's the thing. Your calculator can actually graph this for you. Check this out. What you are going to have to do is go to mode. I suggest you're in radian mode. However, your calculator has always been in function mode, meaning rectangular, x and y. What you have is this option right here, polar. When you now go to your y equals, it is going to say r equals instead of y equals. And the button that you used for x will now put a theta. So if we do r equals 4, it's going to give you a circle. Now it looks kind of more like an egg. If you go to zoom square, option 5, it will go ahead, it will make it more circular looking for you. Okay, isn't that neat? Okay, so then if you would like, you can go ahead and you can type 4 cosine theta into your calculator. And what you should see is this is a circle as well. This is something you really should be able to do without your calculator though, so let's look at how to do that. The best way is to convert this into rectangular. So we would go ahead and multiply by r on both sides. We saw us doing this yesterday. The benefit of doing that as opposed to squaring both sides is that you'll get a 4r cosine theta on your other side, and r our cosine theta, having trouble speaking, is really the same as x. Okay, so I'll convert x squared plus y squared equals 4x, and then we'll move our 4x over. Oops, it should be subtraction. Okay, and then we will need to complete the square. So this should be a plus 4, and again, we'll do the same thing on the other side. So a plus 4. That makes this x minus 2 squared plus y squared equals 4. So this is, again, the equation of a circle, and it would have a center at 2, 0, and the radius would be 2. Okay, which we can see based on our picture. It looks like the center is about at 2, 0, with a radius of 2 because the diameter is 4. So the way we would graph this is we'd come over 2, 0, and then radius is 2. You're just going to go over 2, and then up 2. So you want to be in line with this circle here, down 2. So in line with this circle there, and then you do your best to make it not look like an egg, which is challenging. All right, so basically it's equivalent in size to the circle that I just did in blue, but it's been shifted 2 to the right using our transformations. All right, let's do one more of these, and then the last thing we're going to talk about today are cardioids, which is on the next page. Our cosecant theta. Well, cosecant, you should know, is the same as 1 over sine. So we're going to rewrite it like this. And then this is similar to a problem that we did in our last lesson, in which we will cross multiply. All right, so now by doing that, it looks just like the problem we did for number 5. So now we can proceed in the same way. Multiply it by r on both sides. We'll get r squared equals 2r sine theta. R sine theta is going to become a y. Move your y over. And then we will have to complete the square here. This one will have a shift in the y direction as opposed to the x direction, like our circle right here. So we'll have negative 2 squared, or negative 2 divided by 2 squared. That's a plus 1 and a plus 1. And then we can go ahead and factor it. So this circle would have a center at 0, 1, and have a radius of square root of 1, which is still 1. All right, so let's graph it first, and then we can check on our calculator if that is correct. So center at 0, 1, and radius of 1. So up 1, right 1, and again, it's kind of hard to draw once you've shifted it. You want to compare it to the circle of the radius 1 that's in the center. That was a little too big, but it should essentially be the same size as this guy here. Okay, so now what I'm going to graph is this guy, the one that's r equals 2 sine theta. And there it is. Okay, mine's a little too big, but that's the basic idea. All right, so next we have something called a cardioid. A cardioid is a graph in the form of r equals a plus or minus a cosine theta, or r equals a plus or minus a sine theta. If you have a plus a sine theta, you have a max in the positive sine direction, sine meaning y. If you have a minus a sine theta, you have a max in the negative sine direction, again, that's going to be y. And then for these guys, the cosines, you will have a max in the positive or negative x direction, or cosine direction, based on whether you have a plus or a minus. All right, now again, these are ones that you can graph with your calculator. However, you should be able to graph them by hand, which means that I am expecting to see you create a table. So what we're going to do is create a table with our four main quartile angles, which are 0, pi over 2, pi, and 3 pi over 2. Now, technically speaking, we are in r comma theta. However, it is easier to find your angle first, so I generally put theta and then r when I am writing, making my table, but remember when you plot your point, r should come first. If you want to just have r comma theta and fill in your thetas first, that's okay as well. All right, so these are the four angles that you're always going to use. And what we're going to do is we are going to plug each of these values in for theta. And if you know your unit circle, these should be pretty easy to calculate. Okay, so 2 plus 2 sine 0. Well, 0 is over here. Sine of 0 is 0. So it's just 2. Okay, 2 plus 2 sine pi over 2. Sine of pi over 2 is 1. 2 times 1 is 2, plus 2 is 4. Okay, next we're on pi. Well, sine of pi, that's over here, that's 0 again. So this is just 2. Sine of 3 pi over 2, that's down here, that should be a negative 1. So we have 2 times negative 1 is negative 2. 2 plus negative 2 is 0. Okay, and now we'll graph. So when theta is 0, I have a radius of 2. When theta is pi over 2, I have a radius of 4. When theta is pi, I have a radius of 2. And when theta is 3 pi over 2, I have a 0, which is here. Now, when you graph this, now I'm going to type it in. 2 plus 2 sine theta. People hear cardioid and they think heart. Okay, it is not a heart. Look how rounded it is here. Okay, it's kind of more like an apple, or a peach, or whatever. But what you don't want to do is this. No. Okay, that's not what it looks like. It's very rounded. Okay, so it should be coming out like this. Okay, even if you use your calculator, you should be able to have this table. All right, so here's the other thing you should notice. This is a plus sign. What that means is the max, which is this 4, this widest part here, is in the positive y direction, positive sign. Okay, this one is a plus cosine, so that means our max is going to be in the positive x direction, so it'll be over here. Okay, the other thing is that your max is always going to be the a plus a value. Okay, so see how this was a 2 and a 2? That's why our max was at 4. All right, let's try these next 3. Again, you're always going to use the same angles here. 0, pi over 2, pi, 3 pi over 2. Okay, cosine of 0 is 1. 2 times 1 is 2, plus 2 is 4. Cosine of pi over 2, that's straight up, it's 0, so just 2. Cosine of pi, that's negative 1, so we have a 2 plus negative 2, 0. Cosine of 3 pi over 2 is, well, 0, so 2 plus 0 is 2. Okay, and now I plot. At 0, my radius is 4. 1, 2, 3, 4. At pi over 2, my radius is 2. At pi, my radius is 0. And at 3 pi over 2, my radius is 2. And again, if you want to type it in to look at it, you can, but it's going to be the same thing. It's just oriented in a different direction. Again, you really want to round this out. It does not look like a heart. Okay, feel free to type that in your calculator if you'd like. Okay, 2 more of these. 0 pi over 2 pi 3 pi over 2. Okay, so when we plug in a 0, sine of 0 is 0. So we just have a 3. Sine of pi over 2 is 1. 3 minus 3 is 0. Sine of pi is 0. So that's a 3. And sine of 3 pi over 2, that's a negative 1, but this is already a minus. So this becomes 3 plus 3, which is 6. Notice your max 6 is again that a plus that a value, 3 plus 3. All right, so when theta is 0, my radius is 3. When theta is pi over 2, my radius is 0. When theta is pi, my radius is 3. And 6, 1, 2, 3, 4, 5. We're just going to pretend it's right here. And then you can go ahead and graph that. Again, feel free to type it in your calculator if you'd like. But again, the key thing is this is really rounded out. All right, so when you look at number 10, you can probably see that your max is going to be an 8 this time, and our circles are really just not big enough. But what you can do is just like you can scale a rectangular grid differently, you can scale this guy as well. We can say that each circle is actually a radius of 2. So that can help us a little bit. Okay. So plug in a 0. Cosine of 0 is 1. So this is a 4 minus 4. Cosine of pi over 2 is a 0. So that cancels, just a 4. Cosine of pi is a negative 1. This becomes 4 plus 4, which is 8, which makes sense because pi is over here. That's in the negative cosine direction. That's where your max should be. And 3 pi over 2, well, cosine of 3 pi over 2 is 0. So again, 4 minus 4 is 0. Okay, 0, 0. Pi over 2, 4. Remember we changed what the radius of each circle was. So that would be up here. Pi 8. That's this guy, or 8 comma pi, I should say. And then when your angle is 3 pi over 2, we are, oops, that one was incorrect. I forgot that we had the 4 there. So it's at 4, right? Because cosine of 3 pi over 2 is 0, and then 4 minus 0 is 4. That didn't look right. Okay, and then we can draw our cardioid. Again, it's really rounded out, and you can type that into your calculator if you would like. Okay, which I will do just for fun. 4 minus 4, what was it, cosine? Theta. There you go. All right, so that's going to be it in terms of our lesson today. Our next lesson, we will cover the rest of these. Have a great day.